Hello everyone, my name is Adam Michael Anthony Simpson and you're watching my YouTube channel, Adam M.A. Simpson. This is part 2 of my interview with Jorge Meraz, and here we'll be talking about his super interesting research funded by NASA, dealing with bioplastics and creating these bioplastics in a space environment. So stay tuned and yeah, you're in for a treat. So I'm going to pivot into the second portion of the interview, which is the how does your research impact society? Because we're here trying to get rid of the jargon and just like let people understand why science, technology, engineering is important and how our work can benefit them so that they can become interested in our fields as well, and inspire youths to pursue STEM fields in the future. So now your main advisor is Dr. Craig Criddle, and your research is under work done by Cubes, which is the Center for the Utilization of Biological Engineering in Space, the final frontier. You currently design fabrication and modeling of reactor kinetics for the production of biologically produced plastics to 3D print materials in a space habitat. So can you describe your research in a way that we can understand and why it's important?
Yeah. So, my research didn't start out with this frontier, with this idea that we would be involved with like space and NASA. So Cubes is what is known as a space. It's an SRI. A Space Research Institute, and it was one of 2 institutes funded by NASA back in 2016, 2015. But my work initially started and is still heavily focused on greenhouse gases. So greenhouse gases, think of methane, carbon dioxide.
Yep.
All of these things that are emitted into the atmosphere by way of us driving cars, having wastewater treatment plants, landfills, like what have you. Mm-hmm. And so I really wanted to figure out how can we mitigate those effects, right? How can we mitigate all of these gases being released into the environment and use them for something that for something good, basically. And so what connected me with my PI, with my principal investigator, with Craig, Professor Craig Criddle, was that while I was in his class as a master's student, he had talked about these bacteria called methanotrophs. And so if we break that down, methanotroph, methane, methano, and then troph, something that eats something. So methanotroph is a bacteria that eats methane. So it can take methane from their surrounding environment and use it for something good, and that good is making bioplastics.
Yeah.
And so I thought that was super cool. I was like, dang, there's like these little bugs that can eat the gas and then use that to make plastics, and then we can in turn use those plastics to replace plastic bottles that we have. Like, I mean, everything that we have, I guarantee you have one, if not many things in your house that are made of plastics that are produced by petroleum, by way of petroleum or oil. And the reason for that is because it's so cheap, right?
Yep.
They figured out how to do that like very, very early on. And technology has gotten way better for that specific process, and it's super cheap. Now that we're learning these things, not only of like global climate change with CO2 and methane, we're also seeing that we're polluting like our environment, right, with plastics, and these plastics take hundreds, thousands of years to degrade. Like they're not easy to dispose of, and so they're just floating around the ocean or staying in landfills, being burned, releasing all these other toxic chemicals into the environment. And so this research of using bugs, using bacteria to make plastics has been around since, I want to say, like the 80s. But the technology to make it feasible, to make it inexpensive, and for it to compete with traditional plastics is just not there. And so that's where I come in, where I develop these new technologies, develop these new systems so that we can make them cost competitive with traditional plastics. Because that's really the kind of direct route into being able to compete, is like, can you make it cheaper?
So then how does the space habitat section come in?
So that one took me by surprise, to be honest. The leading institution for this research, the institution that kind of put that together, along with Stanford. So we work with 5 different schools, but the leading institution is Berkeley, UC Berkeley. There's University of Florida, Utah State, I believe. What's the other one? There's us, Stanford, and then UC Davis. So this consortium of schools, each one has a specialty. So like UC Berkeley does genetic, microbiology, engineering. We do a lot of like the plastics engineering. Other schools focus on like food, how are we gonna have produce food in space. But we were essentially invited kind of to be part of this consortium because of our expertise, because of Craig Criddle's expertise in bioplastics and methane and CO2. So the idea was that, or the idea of this SRI is to send a crew of astronauts to some space habitat, Mars, for example, where the colony or the habitat can be kind of self-sustaining. So you have food, water, energy, and materials, and we from the material side. And so they were really interested in 3D printing our plastics. And so then my PI was like, oh, this is like a pretty cool, research opportunity, and it could excel kind of what we're doing here for Earth, while at the same time having applications in space. And so the concept is the same. Like I'm trying to develop technologies to make plastics cost competitive. And so the idea with NASA is that we're doing the same thing. We want to make a lot. It's really a chemical engineering problem of like, how can we make as much of this product as possible? Optimize it so that we can have astronauts have tools like wrenches and bottles and baskets and like things to do research. And so we want to make as much of that product as possible to be able to 3D print those materials. So they're gonna have. There's another group within Stanford who works on the 3D printing aspect, and they're like, okay, let's take your plastic that you're making and see what we can make with it. What can we 3D print it? How can we optimize the 3D printing? So I make the material and someone else processes it.
Awesome.
And so that's kind of like the driving force for NASA is having basically biological engineering in space, like how, and that comes as a result of one, also mitigating costs. Like it costs, they gave us an estimate, I forgot what it was, but it costs a lot of money to take 1 pound of material. So if we can use biology to just take them, freeze them, then take them to space, and then do all of that stuff over there. It's much more cost effective for them to be able to have kind of like a kit. We're developing a kit, like a little suitcase of materials that they take, and they can open up and then start doing food, start having materials.
That's cool.
Yeah,
Awesome.
where that project comes in.
That's cool. I love how you circle back and, explain how it will be beneficial to us here on Earth, and then to scientists in space with microbes that weigh a lot less than bringing the technology to produce these plastics in space. So it's more cost effective, etc. So now I'm going to go into the final question, which is my favorite question. And the answers always change and sometimes surprise me. So, what are common misconceptions of graduate school that you'd like to dispel for viewers? Particularly, think like undergrads that thinking of going to graduate school or weren't exposed to what graduate school is. So, yeah, how common misconceptions that you'd like to dispel for them?
It's a good question. Ooh. Common misconceptions. I would say, don't think that you're not prepared. I think a lot of first gen folks that are thinking about grad school, and this is like kind of very fresh in my mind because we were for the School of Engineering, we were actually holding panels this past week from all 9 different departments in engineering. Basically getting faculty to be one-on-one with students and talking about grad school. And a lot of them, we were really focusing on folks who are historically underrepresented in engineering, and a lot of the questions that came up were, I don't think I'm ready because of my GPA, or I don't, I'm not a good test taker, and all these other things. And it was like, just because your GPA or your GRE or what have you, just whatever qualifications you think you don't have, because on paper, just throw those out the window. Like when it comes to grad school, doing good in classes or doing good in tests they're not good indicators for what would make a good graduate student. Especially not when you're doing research. Like when you throw classes out the way when you're doing research. Not like I don't want to say like don't
try your best, but don't kill yourself.
Like it's when you're doing research, you are venturing into something that's not in the textbooks. You're creating knowledge, right? So just because undergrad, you got like a C or a B or something in some STEM class, it doesn't mean you're not ready. Like don't look at that as bad or as something that could limit you. When you're applying to grad programs, that is one of, at least in my experiences with interacting with other faculty, that's one of the last things that they look at is your GPA. And a lot of programs are actually getting rid of the GRE. There was a study, many studies have come out about GPAs and GREs and how they are heavily, what's the word I'm looking for? I guess related to, or there's a good indicator between high grades, high test scores, and income level, right? And that's just it's just a fact. And so it's being recognized by a lot of institutions, and they're starting to realize like, oh shoot, like I'm losing out on a bunch of potential like amazing graduate students because there was this minimum threshold of like, oh, you have to have this GRE or this GPA. But I can speak for Stanford that there is no minimum GPA, there is no minimum GRE. There's not. That's like being gotten rid of by a lot of departments, and so I think one of the worst things that you can do, and this came about as my experience from applying to Stanford, as a McNair scholar, when I was getting exposed to research, they brought us to California to a conference at Berkeley, and then they brought us to Stanford. And I was like, I didn't know anything about Stanford before my junior year of undergrad. And I was like, oh my, these places exist. This is wild.
Yeah.
I got exposed to it. I interacted with someone who works at Stanford, and I told them about my experience. This was like 6 years ago now. So a lot has changed since then. But I told them like, hey, I just started research. This is my GPA. Because I am the type of person that I want like a really blunt answer. Like, just tell me if I can get in.
Yeah, same.
Yeah. And they told me no. They told me, I don't think that you're gonna get in.
Wow.
Like, you should take some time off and, you know, think about if grad school is for you. Maybe do some research in the meantime. And that crushed me. I was crushed. I was like, I'm doing research. I like in school. Like, I thought I was on top, and they just threw me way down. And so at that point in time, I told myself no. This other person told me no, but then I was telling myself, no, I'm just not gonna apply. It's not worth it. Like, I shouldn't do it. I ended up having like a good experience presenting my research, and I was like, you know what? I'm just gonna apply. I think the worst thing that I could do at this point in time is like cancel myself out. Like, I'm gonna make like faculty or whoever's reading my application, they need to work to tell me no, to tell me that I'm not ready. And so that's like one of the biggest things that I want anyone and all y'all that are watching this to take away from this. It's like, don't sell yourself short. Don't tell yourself no. If you already don't apply, you're making Stanford or Berkeley or any school you apply to, you're making their job easier by not having to look at your application. Make them work.
Exactly. I completely agree. I always tell students to, shoot for the stars. Don't over rationalize. Like, just know how much work you've done and just, go for it. Because a lot of times when a professor or some evaluator just sees a GPA or, a test score, they haven't seen the full picture. But I know so many cases with students that didn't have an amazing GPA, but amazing research that they still got into grad school because obviously they're gonna prioritize the research over. So I'm glad that you said that. And I hope it encourages a lot of undergrads out there to apply, shoot their shot.
And if you want to get more research experience, look at some of the programs that we offer for the summer.
Surf.
Surf is a great example of, we're looking for the students who who we want to basically come to Stanford or apply to grad school, any grad school, and you'll be part of a research experience over the summer. The application is open November 1st. Another plug, but Surf is a great example of how we try to prepare undergrads who that they're not ready.
Yeah,
that's cool. Like, you're ready.
Yeah,
we're just here to support you and give you as much knowledge as we have about the process, so that it's not intimidating. I think a lot of people think they look at like the Stanfords of the world, and they're like, oh, I couldn't see myself there. But just look at us. Like, I never in a million years that I think, I would be here.
Yeah.
To this day, I'm shocked. Like, sometimes I wake up and I'm like, I cannot believe I'm here. It's a struggle. I'm not gonna lie, it's a struggle, but it's possible.
Yeah.
And I encourage y'all to like reach out to me. Reach out to any of the other people that Adam has interviewed. Like, we've been through it. We're doing this work because we want to do it, and we're passionate, and like we want to see more of y'all here. Like, simple as that.
I love that. All right, Jorge, this was an amazing interview, and I love all that you had to say. And I'm hoping that we will inspire young scientists and engineers to apply and seek these opportunities that you've explained and offered to them. And so I'm going to end the interview now. But thank you for sharing this time, and I wish you all the best, and hope to see you when all of this pandemic thing goes away. Yeah.
It'd be
awesome.
Nice.
All right, man. See you. Peace. Thanks for watching this episode with Jorge Meraz. I found this interview to be super interesting. Jorge has a lot to say, and stay tuned for next week. Please like and subscribe to the channel because it helps to create this content.